Today we're going to practice more with mean absolute deviation. And remember that mean absolute deviation is a measure of variability. Okay, other measures of variability that we have discussed have been range and interquartile range. Mean absolute deviation is a measure of variability that shows the average distance between each data value and the mean of the data set. Okay? Mean absolute deviation shows the average distance between each data value and the mean of the data set. You can use the mean absolute deviation to compare the variability between two or more populations. Okay, so in our first example, we're going to practice calculating the mean absolute deviation. All right, it says to calculate the mean absolute deviation, or the MAD, for the following data set: 3, 9, 2, 6, 4, 7, 3, 8. All right, the first thing that we're going to do is calculate the mean. So again, in order to figure out the mean, you're looking for the average, so we're going to have to add all of these numbers together. Okay, and when we add all of them together, we come up with a sum of 42. 42 is the sum. And now we have to divide by the number of values to get the average. 1, 2, 3, 4, 5, 6, 7, 8 numbers in that list. If you divide 42 by 8, you're going to get a mean of 5 and 25 hundredths. 5 and 25 hundredths. After you calculate the mean, then you need to figure out what is the distance from the mean for each data point. So for each one of these numbers, I have to figure out how far away are they from 5 and 25 hundredths. So again, we're going to do some subtraction. 5 and 25 hundredths minus 3 is going to be 2 and 25 hundredths. 9 minus 5 and 25 hundredths is 3 and 75 hundredths. 5.25 minus 2 is 3 and 25 hundredths. 6 minus 5.25 is 75 hundredths. 5 and 25 hundredths minus 4 is 1 and 25 hundredths. 7 minus 5.25 is 1 and 75 hundredths. 5 and 25 hundredths minus 3 is 2 and 25 hundredths. And then finally, 8 minus 5 and 25 hundredths is 2 and 75 hundredths. Okay, so again, you start by calculating the mean of your data. Then you figure out how far is each piece of data away from that mean. That's what we just did. And now we're actually going to calculate the mean absolute deviation. So in order to calculate the mean absolute deviation, we're going to find the average of these distances. So now we're going to have to add these distances together. Okay, so when we add all the distances together, okay, again, we're calculating the MAD now. All right, we add all of those distances together, and that's going to give us a value of 18. Now we have to divide by the number of distances, 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay, and if you do 18 divided by 8, that's going to give you a mean absolute deviation of 2 and 25 hundredths. In the next example, we're going to calculate the mean absolute deviation for the following set of data. There's our list of data. Okay, and we're going to round all of our answers to the nearest hundredth. So again, step number 1, we need to calculate the mean. So first thing we're going to do, we're going to add all of our data together. Okay, when we add those numbers together, we should get a sum of 126. And now we need to divide by how many pieces of data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if you do 126 divided by 11, you're going to get 11 and 45 hundredths repeated. To the nearest hundredth, well, again, there's going to be another 4 right here, which is not enough to round up our 45 hundredths, so we're going to keep that as 11 and 45 hundredths. Okay. For step number 2, now we're going to find the distances from the mean. So what I want you to do, I want you to create a table like what we had back up here. Okay, so make your numbers the first row, and then your distances from the mean That's going to be your second row. Okay, so I'll give you some time to do that. So here's the table that I created. Again, all of the numbers from the data are in the top row, and then I found the distance from the mean for each of these numbers from the average. So I did 11.45 minus 3 to get 8.45, 11.45 minus 5 to get 6 and 45 hundredths, etc. So these are all the distances from each data value from the mean. And now we're going to use these distances to help to calculate the mean absolute deviation. So again, we're going to average all of these distances together. So the first thing we're going to do is add all of the distances together. If you add all of these distances, that's going to give you a sum of 54 and 55 hundredths. Okay, and now we need to do a little division. There were 11 pieces of data there, so we're going to divide by 11. And if you do 54 and 55 hundredths divided by 11, you get the following decimal, 4 and 95909, and that 09 is going to repeat. Okay, but the direction said to round to the nearest hundredth, so we're going to take that number now and we're going to say that that's approximately, okay, this 9 here is enough to round us up to 4 and 96 hundredths. So this number is your mean absolute deviation. Okay, you can also informally compare two populations using the mean absolute deviation, and that's what we're going to do in the next example. The tables below show the number of penalties for 7 random teams from the AFC and NFC. These are the two conferences in football. Which conference shows more variability in the number of penalties? More variability in the number of penalties. That's what we're going to look for when we're finding our mean absolute deviation. Okay, so the top table shows the random NFC teams and the number of penalties that they had. And the second table shows the random AFC teams and the number of penalties that they had. Step number 1, we're going to find the mean number of penalties for each conference. So let's start with the NFC. Okay, to find their average, again, we need to add up all of these penalties. If we were to add up all of the numbers in that list for the NFC, that should give us a number of 644 for the sum. Now we need to divide by the number of teams in our box here. 1, 2, 3, 4, 5, 6. There are 7 teams there. Okay, so if you do 644 divided by 7, that's going to be an average of 92 penalties per team. Okay, 92 penalties. Let's do the same thing for the AFC now. Here's their number of penalties. We need to add these numbers together first to get the average. When we add the numbers, the sum, we get 588. And again, there are 7 teams that they randomly chose, so we'll divide by 7. And if you do 588 divided by 7, that's going to give you 84 penalties on average. Okay, so now that we have the average for each conference, now step 2, it says find the distance from the mean for each team in each conference. Record this in the tables above. Okay, so we're going to find all of these distances. For the NFC, again, remember that the mean was 92. And for the AFC here, the mean was equal to 84. So when you do your subtractions for the NFC, okay, you're going to have to use these numbers with 92. When you do the subtractions for the AFC teams, you're going to use these numbers with 84. Go ahead and find those distances. So I found the distance from the mean for each conference. Just verify your numbers in your table with mine. Okay, and now we're going to use these distances to help calculate the mean absolute deviation for each conference. That's what we're doing here in step 3. So again, when we find the mean absolute deviation, we're going to look for the average of these distances. So let's start with the NFC. We're going to take all of these distances and add them together. When we add all those distances together, we should get a sum of 156. And again, we have to divide by the number of teams. In this case, we had 7 teams in the list there. So if you do 156 divided by 7, that's going to give you 22 and 285,714. And let's go to the nearest tenth with this. Okay, to the nearest tenth. Okay, that's going to look like 22 and 3/10 penalties is their mean absolute deviation. Okay. For the AFC, now we're going to take these distances and we're going to average them. So let's add them together first. When you add all of the distances together for the AFC, you should get a sum of 74. There were 7 teams again in the list, so 74 divided by 7 gives you the decimal 10 and 5,71428. And again, let's go to the nearest tenth with that, so 5/10, but that 7 right there is going to round us up to about 10 and 6/10 penalties. Okay, so these are the mean absolute deviations for each conference. So the mean absolute deviation for the NFC was 22 and 3/10 penalties, and the mean absolute deviation for the AFC was 10 and 6/10 penalties. And again, the question, if we go back up to the top, the question wanted to know which conference shows more variability. Which one has more variability? Okay, so more variability is going to mean a higher mean absolute deviation. And if we look between our two mean absolute deviations, we can see that it's the NFC that has the higher mean absolute deviation. So we're going to say that the mean absolute deviation, and I'll go ahead and abbreviate that MAD, the mean absolute deviation is higher for the NFC. Okay, this means that these teams show more variability in the number of penalties. Compared to the AFC teams. Okay, the mean absolute deviation is higher for the NFC. This means that these teams show more variability in the number of penalties compared to the AFC teams. The AFC teams are more consistent. Okay, when the mean absolute deviation is lower, that means there's more consistency. The NFC has a higher mean absolute deviation, which means that they are less consistent.